All right, so at this point, you should have submitted the cooldown. Let's go over it. So here's a pattern of squares. Write an equation to represent the relationship between the step number and the number of squares in the pattern. Briefly describe how each part of the equation relates to the pattern. So again, I need to actually look at the steps here. So I see this like diagonal going on, that there's two 1x1 squares. Okay, that doesn't give me much. So I'm looking at step 2. I still see some type of like diagonal going on, but now this is a 2x2, and this is a this is a 1x2. Okay, still not that helpful yet. So I'm gonna look at the next one. This is a 3x3, and this is a 1x3. So I think I'm starting to see the pattern. So now if I go back to the first one, this is a 1x1, and this is a 1x1. So it looks like this section over here to the left is an array. So step 4, I think I'm going to have a 4x4. 1, 2, 3. So I have a 4x4. But now I also know, because this is a 1x1, this is a 1x2, it's a 1x3, it's going up by 1 each time, that this is still going to be a 1 in terms of the row, but it's going to have 4 columns. So that is me using what I have, looking at them, trying to see what they have in common to create the next step. And that is how I'm going to write an equation. So again, this is a 4x4, 3x3. So I see that whatever my step number is, I'm going to have n squared. And it says, write an equation to represent the relationship between the step number and the number of squares in the pattern. So it's just asking me for the number of squares in the pattern. So this is a 1x1 plus 1. This is a 2x2 plus 2. This is a 3x3 plus 3. So it's going up by 1 each time. And that is also directly correlated to the step number. So whatever the step number is how much is going to be added on. So I'm just going to call that n, my step number. And let me just double check that this actually works. If y is 3, I would get 3 squared plus 3, which is 9 plus 3, which means I should have 12 squares. So this is correct, because if I count how many squares I have here in step 3, there are 12. So this is my equation. And again, the n squared part came from 1x1, 2x2, 3x3, 4x4. The step number multiplied by itself. And then the plus n came from this diagonal box. This is adding 1 onto it. This is adding 2 onto it. This is adding 3. This is adding 4. And it's always directly correlated to the step number itself. Then it says, is the relationship between the step number and the number of squares a quadratic function? Explain how you know. Well, this is kind of an easy question if you know what to look for. Yes. So is the relationship between this quadratic? Yes. Explain how you know. Because n squared. So because of the fact that the equation that I came up with was n squared, that in and of itself is quadratic. Quadratic is any time you have squared, or to the second power. So that is a really easy way to just say, yeah, I know it's a quadratic function. I know what's happening here is quadratic because it's being squared each time. It's going up each time by itself. So 1x1, 2x2, 3x3, 4x4, which is why I came up with this equation. So yes, therefore it is quadratic.